grade 12s. Today I'm working through a past paper. I've got the 2018 IB Paper 2 final, and I'm going to work through the mechanical analytical. Now the mechanical analytical is a mark for 20 marks, and you want to complete this in a time frame of maximum 20 minutes. Now in your reading time, what you want to do is that you would like to read this question last, so that as the reading time finishes, you are able to start the analytical question. So let's take a flip over and go through the mechanical analytical question for the 2018 paper. I am starting this at 12 o'clock, so I need to finish by 12:20. Now, the relevance of going over these past papers is to familiarize yourself with the types of drawings that you can expect in your matric final paper. The other relevant aspect here is that in 2018 a new examiner was appointed, so from 2018 it has been the same examiner, so it's a good way of getting used to the type of questions that you should expect to get in your final paper. Okay, question 1. What scale is indicated by the drawing? If we come down here, we can see our answer there. Question 2. How many parts? We're coming down here and we're going to add this up. 2, 3, 5, 6, 7, 8, 9, 10, 12, 13. Okay, the bearing, question 3. So the bearing here is steel. Unspecified radii are a radius of 3. Diameter of the ball bearings. The ball bearings are part D. So that's part D. So it's 10 of diameter 10. So the diameter is a diameter of 10. What features part 1? Okay, so here's part 1, this little hidden detail aspect here, which is showing this aspect, which is a keyway. Feature 2. Okay, so there, to me, that is your concave type of arc, where they're joining two pieces, and that is known as the fillet. Sectioning in part A. So this is where the sectioning has been flipped over in the actual space here, and that is a revolved section. Okay, part B, where they've cut the triangle off the corner, is a chamfer. Type of hole is shown in feature 5, part K. There's part K. What type of hole is that? So here's the hole, we see it in detail. The hole isn't going all the way through, so it will be dark in there, which my idea is that it's the blind hole. Okay, it's dark inside because you can't see through, and that is a blind hole. Okay, these double lines there mean that the shape is symmetrical, so it is mirrored. Okay, so it's a symmetry. abbreviation. A circle diameter. How many surfaces need to be machined? So here is the machining symbol, if we had to count them. So it's sometimes nice to take a highlighter and you can mark them off. There's 1, 2, 3, 4, 5, 6. Okay, hang on a sec. This is different, that's got a circle. So there's 1, 2, 3, 4, 5, 6. Almost made a mistake there. So there are 6 that are machined. 2 are saying that there mustn't be any machining. Okay, type of sectioning in 7 on part J. Now the clue here is this wavy line, and the wavy line always represents a part section. What is the length of the dimension at 8 in part I? So here is the circle on the inside of that shape of your nut, and this is where you need to know your different values. Though this one should be, if we just go and look at our part here, it's the M16. So we need to calculate the inside value. So it's the M16 nut. Now that's the inside hole, and this is an M16. So the thread value on either side will be 16 divided by 10, 1.6. So if we're taking off a distance of 1.6 on that side and 1.6 on that side, it means we have got a diameter of 16 minus 1.6 minus 1.6, which gives us a measurement of 12.8. What is the length of the shaft? Here is the shaft, so we need to add up all those measurements. You could write them down if you wanted to. 5 plus 25 plus 73 plus 49 gives us an answer of 152. Which part prevents the shaft from turning in the frame? So anything here, sometimes it helps turn, sometimes it doesn't. So there, when the shaft fits in, we've got this little aspect here, which is the keyway. So the part that's going to prevent it from turning will be part G over here, which is the key. Last question, in the space below, draw the neat freehand of the welding symbol indicating the fillet weld all around. Now a welding symbol requires you to draw an arrow pointing to the part that needs to have welding. So there's my arrow. Then the information goes on here. So the weld all round symbol is a circle at this bend here. So maybe you've got a little circle or circle stencil. Draw that circle, there's the weld all round, and the fillet symbol is the triangle. So there is the triangle indicating a fillet weld, the circle indicating the weld or round symbol, and our arrow. Okay, they did ask freehand, so I suppose I shouldn't have used my ruler. And there I'm finished in at 12:08. So I've now got roughly 10 minutes that I could add to another drawing.